Explain. Now I am going to explain Einstein's photoelectric equation. Let it is a metal body, let it is tungsten. It has many free electrons. When these free electrons are getting sufficient amount of energy from the incident light, those free electrons will be able to leave the metal body. Now, the electrons which are present just at the surface, they need least amount of energy to leave the metal body. But the electrons which are present below the surface means this is the surface of the metal body and below the surface means inside one. Okay. So, the electrons which are present below the surface, they need more energy to leave the metal body. Now, to establish Einstein's photoelectric equation, we have to consider the electrons present just at the surface of the metal body. Now, let when wavelength of the incident light it is 2400 angstrom, then the electrons present at the surface are able just to leave the metal body. Okay. So, corresponding wavelength is known as threshold wavelength. So, threshold wavelength is the maximum value of wavelength for emission of electron. So, what is the corresponding frequency? This hertz. If you solve it, you will get the value. Okay. So, this one is the minimum frequency. Threshold frequency means minimum frequency with which emission of electron is possible. Threshold frequency means the frequency of the minimum frequency of the incident light because of which the electrons are able just to leave the metal body is known as threshold frequency. So, what is the corresponding energy of the incident photon? W0 H into F0. If we do the calculations, then I have converted it into electron volt. I have got 5.156 electron volt. That means this should be this is the frequency associated with this wavelength. So, 5.156 electron volt is the frequency, is the energy associated of this wavelength. So, this is the minimum energy required by an electron to leave the surface of tungsten metal. So, that is work function for tungsten metal. Now, if wavelength of the incident light is less than this, wavelength is less, then energy will be more. Okay, because what is the formula for energy? Energy E or W, anything you can write, H C by lambda. How are they related? Inversely. So, if wavelength is less, energy will be more. Okay. Now, wavelength is 1600 angstrom, means wavelength has been decreased. So, now energy of incident photon is more. Then what will happen? What is the corresponding energy associated with this wavelength of light? The energy associated with this wavelength of light is 7.734 electron volt. Now, out of this much energy is required to leave the metal body by an electron. So, rest means now this is the incident energy and this energy is required by the electron to leave the metal body from the surface. Okay. So, the rest amount of energy is this much and this one will be converted into kinetic energy of the electrons. That means by using 5.156 electron volt, electron will leave the metal body, and with the rest amount means with 2.578 electron volt, the electron will start to run. As the electron is in motion, so it will have kinetic energy. I have written here max. Why? Maximum kinetic energy, because I have considered the electrons present just at the surface. So, they will run with maximum kinetic energy. But if you consider the electrons which are below the surface, they need more energy to leave the metal surface. So, their kinetic energy will be less than this value. Okay, and to establish Einstein's equation, we will consider only the electrons present at the surface. So, they will have maximum kinetic energy. So, W minus W0 is equal to half mv max square, WHF, W0 HF0 is equal to half mv max square. This is famous Einstein's photoelectric equation. And be careful about one point. Threshold frequency means minimum frequency, but in terms of wavelength it will be maximum wavelength. Why? Because frequency and wavelength, they are inversely proportional to each other. F is equal to c by lambda. Okay, they are inversely proportional to each other.